Hello, my name is Dr. Sean Dongard with Washington State University team working in collaboration with the Extension Collaborative on Immunization, Teaching, and Engagement, or EXCITE. This is one of three science media literacy modules as part of the Getting to the Heart and Mind of the Matter toolkit. So there are many other modules for you to use to help you learn from the toolkit. You can watch any of our other videos about motivational interviewing, science media literacy, or neuromarketing by clicking the link to each of the modules in the description for this video. I'm presenting about science media literacy, and specifically this module is about what science media literacy is and why it matters. The point of this series is that we have to help people find trusted sources and trustworthy information. We're not trying to tell anybody what to think, but we want to help you find trustworthy sources and information that can help you make decisions that are best for you. So the other parts in this series are the science behind science media literacy, applying the science media literacy infographic to real-world scenarios, and you can use our toolkit to further your learning and understanding of science media literacy. The science media literacy toolkit authors are myself, Dr. Sean Dongard, and Dr. Erica Weintraub-Austin, who present the second module in this three-part series. A little bit about me is that I study health communication, media literacy, and misinformation. And if you want to learn more about my research and see some of it, look me up on Google Scholar and other publications that I've had, and you can learn more about that research. And mostly it's about vaccines and misinformation. So let's get into it. So this session is going to help you describe what science is, describe what science media literacy is, and explain how science media literacy affects decision making, and learn science media literacy skills to verify information. So the first question of what is science? Some of these definitions that we've had in the toolkit are right here, like a system of acquiring knowledge. The system uses observation and experimentation to describe and explain natural phenomena, or knowledge from the careful study of the structure and behavior of the physical world, especially by watching, measuring, and doing experiments in the development of theories to describe the results of these activities. Or with science literacy, an understanding of basic scientific terms, concepts, and facts, an ability to comprehend how science and tech generates and assesses evidence, and a capacity to distinguish science from pseudoscience have become widely used indicators of basic science literacy. So if you think of science as only facts and terms, that's a very narrow view of understanding what science is and how it works. There's a lot more that goes on in trying to explain this world around us and to generate this knowledge. Science strives for explanations of how and why. Explaining science is much more difficult than just saying, here's a fact, or here's some fancy words, and this is what science is for you. But we're trying to find solutions to problems. We're all trying to figure out how to explain the theoretical and practical ways of solving problems and understanding this world around us. Not all of us are as lucky to work in a scientific field. And even if we do work in a scientific field, not all of us are as familiar with what other scientists do in their work. So many of us need to learn to become a competent outsider, or figuring out how to understand science when we ourselves are not scientists. So it begins with understanding that science begins with uncertainty, that they don't always know the answers to the questions right away, that it takes time, and there's a lot going on with this understanding of unsettled questions that still need to be studied. We all saw that during the pandemic when science took time to figure out what the questions even were and how to answer them, and that process took time. After they answer some of those questions, it's not always a one and done. There's not one study that becomes done and then all of a sudden, oh, yay, we found the answer. There's a lot more that goes into it. We need the peer review process. So peer review is other experts look at the work one scientist does or a group of scientists do, and all these other scientists determine whether they followed uh, rigorous and valid and reliable ways of finding their evidence for solving their problems and answering their questions. The expertise it takes to understand science can be a long time. People go to school for a very long time sometimes to be experts in their field, and they take this schooling and apply it to the problems that they face. It doesn't always mean that their expertise lines up with the questions that they do, and that's something that we need to be aware of. So if you see a lawyer trying to answer a question about biology, you might want to question that. But if you see somebody whose expertise lines up with what they're studying, you can usually trust that what they're finding or what they're saying on the subject, they have credibility in that area. There's also consensus that comes in science where not everybody agrees in science all the time. There's always going to be disagreement, but if there's a general agreement towards a direction on what understanding we have, then that's considered a consensus. As long as the majority is agreeing that way, then we can say that's where we understand it up to this point at this time with these findings that we do have. We also need to understand that there are political actors and other people that are trying to undermine this process for their own agendas, and they might try to create doubt in the scientific process or in science in general. Understanding that can help us to face some of this, but all of us, as we try to become these competent outsiders, can really start to understand science better. To put it simply, science is a process and it takes time. There are multiple people all working to do this over time. And because it's continually ongoing, even after we do find some things, we still continue to study it as scientists, all trying to understand this process as it goes along. And as it's communicated to us, we try to understand it as well as audiences. Now, I want you to think about these questions. You can pause and consider them on your own or discuss them as a group, or you can continue to watch this video and that's fine too. But think about how science is communicated and how do we know when we can trust a scientific source? Imagine that you discovered something on your own and you figured it out. You went through this process to discover this thing. How would you communicate it to other people? Would you tell newspapers? Would you write a blog post about it? Would you post it on Facebook or Twitter or TikTok or something? If you did that, what problems would you run into? And how would people know whether you were making it up on your own or whether it was just something to get attention or something like that? How would you make sure that people could trust the findings that you had in this discovery? Those are some of the questions that scientists have to answer and the problems that they face. And that's where science media literacy comes in. Science media literacy is about applying media literacy skills to science information. It's about understanding how science information is communicated through media itself. So these are some of the core principles that apply to science media literacy. So all media messages that contain science information are constructed by people. And so when science information is communicated, it's constructed by that person for a purpose. They're trying to use different techniques, like I said before, with using TikTok or Twitter or something, that's going to require different ways of communicating that information. They're different mediums, and so that different media will require different ways of constructing a message. So media messages that contain science information are produced for particular purposes. So sometimes those purposes are for a newspaper to make money. Sometimes the media messages are to generate interest. Sometimes it's for public health. Sometimes it's to dissuade people from taking certain actions or to help them take certain actions, but not always are the intentions ethical or good. So we have to understand what that is. They have these embedded values and points of view in them, and understanding that from the author's perspective can help you understand it better. People also construct their own meaning from these messages for themselves because we all have our own biases. And the media and media messages about science can influence beliefs, attitudes, values, behaviors, and society. So they have these long-reaching consequences. So when science information is communicated through media, we need a healthy skepticism. It can help us to manage an uncertain and sometimes toxic information environment. Sometimes, like I said, some people don't have the best intentions when they communicate the science information. So we need to critically think about it and figure out the context of the situation. We need to think about what the author's intent is in sharing this, and we need to figure out how to use some of those core principles and skills in science media literacy so that we can better understand whether something is misinformation, whether it can be trusted, whether it can communicate science in a healthy and credible way, or whether it might be hurting people or helping making or assisting them in making bad decisions. So this science communication takes place through all different kinds of mediums. It's on news, social media, marketing, books, films, TikToks, billboards, uh, physical newspapers, all these different media that we encounter all the time. But the important thing is to ask questions about the science that we encounter. We need to figure out the why, when, how, what, where, what else, who said that, why did they say it that way. All of that are science media literacy skills. In our third video, our third module, I'm going to go over how to use this infographic that helps you to use some of those skills in a practical way to verify information. So it's how to recognize misinformation using these skills. And basically, they are consider the source, examine the content, check your emotions, and ask trusted experts. All of those things are important skills that can help you better understand science information and use it to affect your decisions by using evidence-based science to make the best decision that's best for you. Like I said at the first, we're not here to tell you what decisions to make, just that you should base your decisions on the best information out there, using science media literacy as a skill to help you achieve that. So I want to thank you for watching and learning with us today. Again, I'd like to thank the Excite Foundation through its interagency agreement with the USDA, National Institute of Food and Agriculture, and the Centers for Disease Control and Prevention for funding this project. We hope this toolkit is helpful to you and your communities. Thank you, and take care.